Okay, I think I'm recording. Hi, I don't know if you can see me up in the corner. I'm up in the corner if you can see me, but I think it may black out the screen. Anyway, and let me make sure my audio is on. It is on. So I'm going to quickly go over a few things from the exam that you should know, and hopefully this will be quick. So first of all, you should be able to just estimate an angle here. I'm going to draw on this thing because we're estimating this angle. Okay. And you should say, oh, well, that's less than 90. Maybe it's, 50 degrees, 40 degrees, something like that. But, if it's less than 90 or more than 90, you should be able to estimate it. So that is one of the answers. So if we look down here at the answers, we can see, oh, the only answer, 76 is reasonable, but it is 46. 76, it'd be bigger than that. So that's the only reasonable distractor there. It's definitely not 10. 90 is too big. 125 is too big. The next thing is to actually measure an angle. So this one, the only trick here is in measuring this angle is when we have the protractor here, there are two numbers in here. The inside numbers are measuring with 0 over here going around the inside, and the outside numbers are really, you could subtract those two, but it's really if you're measuring from over on the right side here. So this is clearly not 145, which is what it would be if I was going from, let me draw this in. If I was going from, from here to here, then that would be 145. Okay, 140 plus another 5. But since I'm going from here to here, clearly 35, which is the clear answer. All right, so notice 145 is a distractor there. You have to recognize that it's not a obtuse angle. And then, it could be 30, 48, or 26 if you were estimating, but you're not estimating. Next one, 125 is D. The really critical skill that I keep talking to people about is naming things with 3 letters. Now, there's no need to call this thing anything other than D here, but it has 2 other names. One name is EDC, and the other is CDE. Okay, so I can use those points on the sides to help indicate it. So EDC, notice there is not a CDE. That would be a terrible distractor because it would be the right answer. All those others are just, everyone should have gotten that one. Okay. Okay, only trick here is you have to find VAE and then read it. So once again, we are from B through A to E. That's definitely an obtuse angle. So we're going to read, in this case, the inside numbers on this one because I'm getting bigger, 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 bigger. So go past 120. There's 125 right there. So this is like 128. Oh, and there's the answer. Oh, and I think for these, because of the way I've got this done, I think it may always show up to the first answer for me. For you, they're probably scrambled and they may not always show up as the first answer in the list. These are scrambled. But when I build these, I often make it the first one, just so I know it's there. Okay, another skill. If I tell you, these are parallel lines. So if I tell you one of these angles, you should know all of them. If EAD is 110, we know, I'm going to do this on the screen here. We know that all of these obtuse angles have to be 110 because these are parallel. Those corresponding angles have to be 110. I'm marking this very quickly with my finger. And then because this is a straight line here, those have to add up to 180. That's 70, that's 70, that's 70, that's 70. Now I didn't have to do all that because it just asked me for ABF, which is ABF. Where is it? There's A going down to B, then over to F. So it's that 110 angle right there. All right, so that's the 110. And let me close that and scroll up. Another thing you should know, all 3 angles in a triangle have to add up to what? That's right, it's 180. So 68 plus 47 is going to be, if I can do that in my head, 115. And so that means there's 65 left over for the remaining angle X there. 3 angles inside a triangle have to add up to 180. Similar kind of problem here. Let me mark this one. So I got a straight line here. So these 3 have to add up to 180. So 90 plus 70 is 160. So this has got to be 20. This doesn't look like 90, but it's marked as 90. That adds up. I got vertical angles here. So the F has to be 90 vertical angles. The G has to be, wait, wrong. That should be 20. 20. And then this one, once again, I got vertical angles. This has to be 70. So 70, 20, and 90. And so they're asking for angle E, which is this angle right here. And so it's 70. All right. Next one. Quadrilateral ADCB. So if I was actually going to draw this out, which I don't really need to do, but if I was going to draw it out, I could do maybe something like this. ADCB, because we go around, and it is congruent to some other one that I'm going to draw down here, which is EHGF. And I didn't need to do that because it's just asking angle CBA. CBA, B is the actual vertex that we're talking about, and these things are matched up in order. So it's got to match up to GFE. So it's got to match up to angle F, which you'll notice, what is that? Angle B definitely matches up to angle F, which can be named either GFE or it can be named EFG. It can be named either way. So GFE is the correct answer. All right. Corresponding side to DE. So corresponding just means matching. You should know that word. Corresponding comes up all the time. So what's the right answer? Right. So DE is the one that's unmarked here. It's the long one that's unmarked. So the long one that's marked out over here is BA or AB. Oh, so there's several things you should know about transformation congruence. This is not the question. I just had this. Most people recognize this as a reflection or a flip, because I flipped it across this axis. I could also rotate it or turn it to land maybe over here. Let me draw it up here. You know, if I did something like this, if I rotated it, maybe it would look like this. That would be a rotation. And then finally, a translation is maybe I just moved it. Like I moved it over maybe 5 and down 1. It might look like this. Anytime I do a rigid transformation, which is a translation, rotation, reflection, they're going to always be congruent. Congruent means that they're the same size and shape. All the angles are congruent. All the corresponding angles are congruent, and all the corresponding sides are congruent. If only the angles are congruent, we know it's similar. Could be a dilation. But if we don't know anything about the side lengths, we don't know if they're congruent or not. So similar means the same shape, meaning all the angles, corresponding angles are congruent, but congruence means same size and shape. All right. Let's see. And then transmogrification, my favorite distractor word. Shout out to Calvin and Hobbes. Basic proportion problem. This is probably the most powerful tool in your toolbox. I can do 10/6 because I'm doing miles over hours. And once I pick that side, that determines where my 8 goes in the other side, because that's 8 hours. So I need to make sure the 8 goes on the bottom, and I'm looking for miles in the top. How far is miles? And then I'm going to cross multiply. Okay. So 8 times 10 is 80. 6 times x is 6x. And then my last step is divide by 6. And I think that will come out as the 13.3. All right. Length of a missing side. So same thing. These are, because I've got the 2 angles that match up and the 2 angles that match up, I know these are similar. I don't need to know about that third angle. That third angle I get for free. So that angle and that angle, because they have to add up to 180. So once I know 2 of them, I know the third. Okay. And then it's just a basic proportion problem. I can do 7/6 equals 4/x. That would work. Another proportion that would work is I could do the 7/4. So I'm matching, those 2 parts. And then I could do the 6/x. As long as I get corresponding parts either above each other or across from each other, it will work. Either way, you'll notice the 6 and the 4 get multiplied together in both of them. So I end up with 7x equals 24, and then whatever 24 divided by 7 is, which I think is like 3.4. Okay, so there's our answer there. Clear off. You make sure that's the answer. That is the answer. Okay, missing length of this, right? So Pythagorean theorem. Okay, the only trick here is you have to remember that what I have given you is a leg. So there's an extra step. It is not 16 squared plus 20 squared equals x squared. It is x squared plus 16 squared equals 20 squared, which means after you square though, there's an extra step. So I think that's 256. Doing this on the fly equals 400. And then I got to remember to subtract that. If I don't do that, if I accidentally get them on the same side, I'm going to get a number that doesn't make sense for that. It's got to be, it's got to be less than 20. If it's to scale, it's probably less than 16. So x squared equals 144. And then to undo the square, I take the square root. That cancels, those cancel each other out. But if I do it to one side, I've got to do it to the other. So x is equal to 12. And that is our answer. All right. I may cut this short here because I don't want to spend. Oh, A, B, and C. I'm telling you what this is. So this is, let's see, side A is 10, side B is 13. Find the measure of C. Same problem, except it's 10 squared plus 13 squared equals C squared because the legs I have. So I got 100 plus 169 equals C squared. So 269 equals C squared. And once again, it's not 269. That's way too big. I got to take the square root of both of them. Those are inverse operations. So it's C, and then the square root of 269 is the 16.4. This is a good distractor here. If this had been the square root of 269, they both would have been the right answer. Square root of 269 is the exact answer. 16.4 is an approximate answer that most people would recognize. Let's see. All right. And I think this is the last one I'm going to do. Okay, we got X at the top of the wall. If this is our reference angle, what's the adjacent leg? So this is the other important thing that you have to know starting this semester. So this is our reference angle up here, okay? This right here is always our hypotenuse because it's opposite from the right angle. That never moves. But since I'm looking at the X angle up here, this down here is the opposite side, and this is the adjacent side. If I flipped around and looked at this angle down here, the adjacent and the opposite would flip-flop. So what did I ask? The adjacent leg is the 15 feet from the wall. And I'm probably gonna stop there. Maybe I'll keep going and just edit this at the end. Oh, I gotta clear that though. Here are my drawings. Distance, length, midpoint, we just covered that the other day, so I'm not gonna cover it again. There's a bunch of vocabulary you should know, and you should know how to identify a trapezoid. Once again, lots of vocabulary. All of you know how to graph really well. Everybody knows how to put things in the graph, which makes me happy. That's all. Let me stop recording. Bye-bye.